Wah, second bus already. Still cannot get up, sia. Faster. Let's go. Hey bro, I thought you only 2 minutes get the bus. Only 2 minutes.
Hey, you know why we come about the bus? Why? Because it's packed like sardines.
This is a scene all too familiar for NTU students. So NTU Campus Blue Shuttle is key for campus mobility. However, NTU students frequently report long waiting times, unpredictable and inconsistent bus schedules, and overcrowding, which leads to frustration when commuting within NTU campus. So today my team and I will be investigating what exactly is driving student dissatisfaction. Hence, our problem statement is: how can we address the primary factor behind students' dissatisfaction with the campus bus service?
Before we begin our analysis, I'll be covering a few important concepts. The first concept is IID, which is independent and identically distributed. For independence, each pair of sample point is statistically independent. For identically distributed, each pair of sample point follows the overall population of NTU Blue Bus passengers. To ensure that our data is an independent and identically distributed sample, we use random sampling at different bus stops at different times of the day. This helps us to ensure an independent and identically distributed sample. For CLP, it states that the sampling distribution of the mean will be approximately normal when n is more than or equal to 30. To determine the key issues affecting the quality of the Blue Bus service, we surveyed 104 students from different bus stops at different times of the day. As our sample size of 104 is greater than 30, based on CRT, we can assume normality.
When we're looking at students for regression analysis, we are actually looking at the shape and the segment tree of the distributions of all the variables. So for normally distributed variable, we have a students close to 0. And if it's more than 1, we need to reconsider change of variables. And since we do not have any variables that is more than 1 or less than -1 in terms of students, and we do not want to express any terms in percentage, none of the variables will require logging.
Let's have a look at our regression analysis. Our multiple regression model has a p-value which is extremely significant, indicating its reliability. Furthermore, our model's variables adjusted R-square explains about 55% of the variability in NTU bus user satisfaction. Among the predictors, wait time, crowdedness, and error accuracy has statistical significance as their p-value is less than the 5% threshold we have. Notably, among them, crowdedness has the highest statistical significance with the lowest p-value. Thus, with the highest statistical significance and practical significance, we will focus on tackling the issue of crowdedness to increase bus user satisfaction.
Now that we've established that crowdedness is a statistically significant predictor of satisfaction, we wanted to take a look at the raw relationship of these variables using correlation analysis. Our result reveals a coefficient of -0.63, and this tells us two key things. Firstly, there is a negative correlation, which means that the higher the crowdedness of the bus, the lower the satisfaction. Secondly, this is a moderately strong relationship. However, correlation alone does not equate to causality. Hence, we conducted a one-tube hypothesis test to test its significance. For this, we split our data into two groups. Firstly, we grouped high crowdedness as 6 or more on our 10-point scale, and 5 for lower rating for low crowdedness. Our null hypothesis is that the average satisfaction score for high crowded buses is the same or even higher than for the low crowded ones, essentially suggesting no real difference. Meanwhile, our alternative hypothesis claims that satisfaction is actually lower when the buses are more crowded.
After performing a left DOT test, we actually found that the p-value is significantly lesser than the chosen alpha at 5%. And we can therefore reject the null hypothesis and conclude that the mean satisfaction for those in highly crowded buses is significantly lower, as well as seen for the mean for those in highly crowded buses is only 5.506 compared to those in lesser crowded buses with a satisfaction score of 7.958. So in order to improve the overall satisfaction, we think that we will need to tackle crowdedness.
To tackle the crowdedness problem, we aim to implement three solutions.
So first will be exclusive access and priority boarding. To solve the problem of overcrowdedness in the route bus, we can implement a matriculation by scanning system. So this system ensures that only students are allowed to board campus buses by scanning direct tickets before entering the bus. This reduces overcrowding by limiting bus access to those the service is actually intended for, resulting in shorter waiting times for students during peak hours. And to accommodate tourists and visitors, an e-pass system will be introduced. E-pass holders will be allowed to use through chart, but NTU students with valid wage cards will be given priority board, ensuring that NTU students commuting needs are prioritized. Our second solution is replacing current shuttle buses with double-decker buses. Deploying double-decker buses directly increases passenger capacity per train. By accommodating more students per bus, the frequency of buses required to serve the same number of passengers is reduced. This leads to shorter waiting times at bus stops due to the larger occupancy per bus, alleviating the discomfort and inconvenience of overcrowded conditions for students. Lastly, we hope to improve the accuracy by enhancing the real-time tracking of the Omnibus. According to our regression analysis, for every unit in the accuracy, satisfaction increases by 0.23 units. Hence, we propose to improve the real-time tracking of the existing Omnibus app to accurately reflect bus locations, arrival times, and occupancy levels.